Nvidia just made local AI feel dangerous again. Not cute, not slow, not the toy chatbot you open once, watch it crawl through a paragraph, and quietly never use again. I mean fast enough that the cloud AI default starts to look lazy. Because once local inference is pushing toward 200 tokens per second, the question is no longer, can my machine run a model? That was the old question. The new question is, why am I renting intelligence for boring developer work that my own machine can now chew through for free? And that is the part people are going to miss. They will argue about which model, quant, backend prompt, cache setting, and GPU. Fine, those details matter, but they are not the story. The story is that local AI is crossing the line from hobby project into workflow infrastructure. And if you're a developer, that should give you real FOMO, because the developers who figured this out early are going to stop treating AI like a precious metered API call. They are going to treat it like grep, cheap, always on, private, spam it until it helps. And that changes everything. Hey, don't forget to like and subscribe for more like this now. Back to the video. For years, local AI had one deeply annoying problem. It sounded amazing until you actually used it. The pitch was perfect. No subscription, no API bill, no rate limit. No, sending private code to someone else's server. No waiting for a cloud provider to decide your request is allowed today. Just your machine, your files, your model, your rules. Then you ran it, and reality arrived with a fan curve. The model loaded slowly. The first token took ages. The answer crawled out word by word, and the whole thing felt less like a coding assistant and more like a very expensive typewriter having a difficult morning. So most developers made the same mental trade. Local AI is private and cheap, cloud AI is actually usable. For a while that was true. If you wanted speed, you used Claude, ChatGPT, Gemini, Cursor, Copilot, or whatever cloud tool had the best demo that month. If you wanted privacy or tinkering, you ran something local and accepted that it felt worse. But Nvidia is trying to collapse that split. Not with one magic benchmark, with an ecosystem, RTX PCs, RTX workstations, DGX Spark, RTX Spark, local agents, VLLM, llama.cpp, llama LM Studio, speculative decoding, multi-token prediction, better kernels, bigger memory pools. The local machine is being rebuilt as an AI box, not a computer that can also run AI if you beg it nicely, an AI box. And once output speed gets high enough, user behavior changes. That is the whole game. Let us talk about the number. 200 tokens per second sounds fake if your last local model experience was a 7 billion parameter model wheezing through a paragraph. Tokens per second is not intelligence, it is not context length, it is not whether the model will fix your bug, it is just how fast new text comes out. That sounds like a boring benchmark until you use AI all day, because latency changes what you ask. If a model is slow, you ration it, you pace less, you ask only the important question, you avoid the messy prompt because you do not want to watch the cursor blink. You start thinking, is this worth asking? That question kills usage. But if a model is fast, you get reckless. You ask it to summarize the file, then the folder, then the diff, then the failing log, then 5 better names, then the migration plan, then the test cases, then the boring commit message, then you throw all of it away and ask again. That is what cloud AI unlocked. Not just intelligence, casual intelligence, the ability to ask without feeling like every prompt has to be worthy. Local AI always had the cost side. Once you own the hardware, the next prompt feels free. What it lacked was the casual speed side. That is why 200 tokens per second matters. Because at that speed, local does not feel like a compromise for a huge class of developer tasks. It feels instant enough that you keep using it. That is the threshold, not the benchmark crown, the habit threshold. Here's the opinionated bit. Most developers are using cloud AI for work that does not deserve cloud AI. I do not mean the hard reasoning. I do not mean the architecture decision that touches 10 services. I do not mean the production bug where the model needs to understand half your system and still might be wrong. Use the expensive model for that. Use the frontier model when judgment matters. But look at the average day. Half of AI usage is not genius work. It is paperwork with syntax highlighting. Summarize this, rewrite this, explain this error, name this function, generate a test skeleton, turn this JSON into a type, draft a pull request description, search this log, compare these two outputs, make this comment less embarrassing, tell me what this file probably does. That work is everywhere, and it is exactly the work. Local models are becoming good enough and fast enough to own. This is where the FOMO is. Not that your gaming PC replaces every frontier model. That is the wrong fantasy. The real opportunity is routing. Cloud for judgment, local for volume. Cloud for the scary work, local for the endless assistant noise around the scary work, cloud for the thing you would pay attention to, local for the thing you currently burn tokens on because the button is convenient. That is more realistic, and it is more disruptive. Because if local AI takes the boring 70% of your requests, the economics of AI coding tools start looking very different. The product that owns the router owns the margin. The developer who owns the router owns the workflow. And the developer who sends everything to one cloud model because the drop-down default says so is paying for convenience. Maybe that is fine, but at least know what you're buying. This is why Nvidia's local push is so interesting. It is not only selling GPUs, obviously, it is selling GPUs. Nvidia would sell you a GPU to toast bread if it could get CUDA on the toaster. But the deeper move is that it wants AI inference to become a normal local workload, like gaming, like video editing, like compiling, like running containers. The official local AI material now talks directly about RTX GPUs, RTX workstations, RTX Spark, DGX Spark, llama, LM Studio, VLLM, llama.cpp, and local agents. That is ecosystem building, and the hardware story is getting less silly. GeForce RTX is positioned for smaller local models. Workstation cards and Spark machines are for larger models and agent workflows. Spark class systems are being talked about with 128 gigabytes of unified memory and capacity up to 200 billion parameter models. That does not mean every huge model will feel amazing. Memory capacity is not the same thing as speed. This is where people get baited by spec sheets. Fitting a model is step 1. Serving it well is step 2. But the important change is that this is now a product category. A local AI workstation is no longer just someone on a forum with a giant power supply and a suspicious cable situation. It is becoming a thing vendors want normal developers to consider. And once there is a real market, the software improves quickly. Speculative decoding, prefix caching, quantization, and better serving stop being inference nerd details. They become the difference between a model that technically fits and a model that actually feels good. Local AI is becoming less like a science project and more like a stack. The speed jump is not magic, it is memory, batching, and cheating correctly. Generating text is painfully sequential. The model predicts the next token, then it uses that token to predict the next one, then again, then again. It cannot fully know token 200 before token 199 exists. So raw decode speed is tied to how quickly the hardware can read model weights and move data around. That is why memory bandwidth and VRAM matter. Modern inference stacks work around this with tricks. Continuous batching keeps packing work together so the GPU stays busy. Prefix caching reuses the repeated system prompt. Repo instructions, project context, and tool definitions that agents resend constantly. Speculative decoding lets a smaller draft model guess several tokens ahead while the bigger model checks the guesses. If the guesses are right, you get more output for fewer expensive steps. But the speed up depends on the workload. Editing code, rewriting text, completing predictable structure, and making small changes can accept more draft tokens. Fresh generation may accept fewer, so when someone throws around a giant tokens per second number, do not ask only what GPU, ask what workload, ask what model, ask what concurrency, ask was it a fresh answer or an edit heavy job. That is the difference between a benchmark and your actual day, but the headline still survives the caveat because the workloads that benefit most are exactly the workloads developers do all day. Code edits, boilerplate, refactors, structured output, summaries, agent subtasks. That is why the number matters. If your AI coding setup still treats the model picker like the whole product, you're behind. The model is not the whole product anymore. The router is the product, the cache is the product, the local server is the product, the boundary between local and cloud is the product. Because the best coding workflow is not one model. It is a system that knows when to be cheap, when to be private, when to be fast, and when to be smart. A frontier model is still better for a lot of hard tasks. I'm not pretending a local model suddenly has the judgment of the best closed model during a nasty production outage. That is fantasy. But most tools still flatten every request into the same shape. Ask model, get answer, pay hidden cost. The next wave will feel more like a team. A local model reads the file, summarizes the diff, generates the test sub, and catches obvious mistakes. A cloud model handles the risky part. Then local models clean up the output, write the explanation, make the commit message, and update the notes. That is not science fiction. That is just routing. And routing gets better as local inference gets faster. At 10 tokens per second, local routing feels like charity. At 50 tokens per second, it starts to be useful. At 200 tokens per second, it starts to change defaults. Because now the local model is not a thing you wait for. It is a thing you spam. Developers love tools they can spam. That is why fast test loops matter. That is why hot reload changed front-end development. That is why slow continuous integration makes people behave badly. Speed changes behavior. Local AI is finally getting fast enough to change behavior. The cloud companies should be nervous about one specific part of this, not losing the hardest prompts. They will keep plenty of those. The best models are still valuable. The scary part is losing the waste. Cloud AI makes a lot of money from waste. The repeated prompt, the huge context dump, the retry, the agent loop that reads the same files again, the 10 bad drafts before the good one. That waste is tolerable when it is hidden inside a subscription or a credit balance. But once you can move a chunk of it onto your own hardware, your relationship with cloud AI changes. You stop asking which model is best. You start asking which request deserves to leave my machine. That is a much better question, and it is a question tool vendors do not always want you asking, because the convenient answer is always the same. Send it to us, we will route it, we will cache it, we will price it, we will decide which model is enough, we will keep the margin. Local inference attacks that not by replacing the cloud, by making the cloud justify itself. The cloud should be the escalation path, not the default dumping ground for every tiny piece of developer thought. Once you see that a fast local Nvidia box stops looking like an expensive toy, it starts looking like a way to take back the cheap layer of your own workflow. There is a catch, of course. There is a catch. Local AI is still very easy to do badly. You can spend too much money and end up with a machine that looks impressive in a screenshot and feels annoying in real life. You can chase the biggest model, you can ignore quantization, you can run the wrong backend, you can overfill memory, you can set context too high, you can use a model that is smart on benchmarks but weird at code. Then you conclude local AI is overhyped. But that is like compiling in debug mode, benchmarking it, and declaring programming languages are slow. The setup matters. A 32GB RTX card can be fantastic for smaller and medium models. It can also be the wrong answer if you're trying to run a giant long context model that needs more memory than the card can comfortably hold. A Spark-style system with 128GB of unified memory can load much larger models, but unified memory capacity does not magically turn every model into a latency monster. You still care about bandwidth, active parameters, the serving stack, and whether the model is actually good at the task. This is why the best local AI setup is not buy the biggest Nvidia thing you can afford. That is retail therapy with CUDA. The better setup is boring and powerful. A fast local model for instant work. A larger local model for private heavy work. A cloud model for judgment, a router between them, a cache, so repeated context is not wasted. A habit of measuring your own tasks instead of worshiping random screenshots. That is how local AI becomes useful. The developer angle is bigger than chat. Chat is actually the least interesting part. The interesting part is agents, because agents are token machines. They read, summarize, plan, call tools, inspect output, revise, create more context, ask what went wrong, and do it again. This is why agent workflows get expensive and slow. Not because every individual step is genius level reasoning, because there are lots of steps. And lots of steps are exactly where fast local inference becomes valuable. Imagine a coding agent that uses the cloud only for the moments where it needs strong judgment. Everything else happens locally. File map, dependency scan, log summary, test output triage, simple code edits, commit message, pull request summary. That is where 200 tokens per second feels less like a benchmark and more like a new shape of development. Agents do not need one perfect answer. They need lots of cheap intermediate work. Developers do not need every model call to be brilliant. They need the whole loop to move. That is why local inference is underrated. People compare local models to the best cloud model in a single prompt duel. Wrong comparison. The better comparison is workflow throughput. How much useful work can the whole system do before you get annoyed, hit a limit, or stop trusting it? Local AI does not have to win every prompt to win part of the workflow. It only has to be fast enough, cheap enough, and private enough for the jobs where cloud was never special. And those jobs are everywhere. So should you immediately buy new hardware? Not automatically. The FOMO is real, but the purchase is not obvious. If you mostly ask a cloud model a few hard questions a day, do not pretend a local box will magically pay for itself. If your laptop barely has memory free with the editor open, do not expect a giant local model to make your life calmer. If you hate maintaining tools, local inference can become one more little server you babysit, but if you use AI all day, especially with agents, the math starts to get interesting. How often do you avoid asking because the model is slow? How often do you avoid pasting context because it is private? How often do you burn cloud tokens on summaries, drafts, rewrites, and obvious checks? How often do you hit rate limits? Those are the real questions. For that kind of user, fast local inference starts looking less like a luxury and more like infrastructure. Maybe that infrastructure is a beefy RTX desktop. Maybe it is a dedicated local box. Maybe it is a small model running on hardware you already own. Maybe it is not Nvidia at all for your exact setup, but Nvidia is pushing hardest on the idea that the personal AI machine is real. Whether you buy the hardware or not, pay attention to the workflow pattern. Local first, cloud when it earns it. That pattern is going to show up everywhere. The developers who ignore local AI because it used to be slow are making the classic mistake. They are judging the next version by the worst version they tried last year. Local AI is not solved. It is not magically better than the best cloud models. It still has sharp edges and it still depends on the model, the quant, the backend, the workload, the memory, and the hardware. But the direction is obvious. Faster local inference, better local models, better serving stacks, more agent workflows, more pressure to stop paying cloud prices for boring token volume. If you're a developer, you do not need to become an inference engineer overnight, but you should stop thinking of local AI as a toy. Set up something small, route one boring task to it, summaries, commit messages, log explanation, test output triage, tiny refactors, repo notes. Then notice what happens when the marginal cost becomes basically zero and the latency stops annoying you. You ask more, you experiment more, you automate more. You stop treating every prompt like it has to be worthy of a cloud model. That is the behavior change. And behavior change is where platforms are born. Nvidia pushing local inference toward 200 tokens per second is not just a faster benchmark, it is a warning shot. The future of AI coding is not cloud versus local, it is cloud plus local, routed properly. And the developers who learn that early are going to have a workflow that feels unfair.